Welcome, everybody, to episode number 2 in our AI in e-mobility series. In our first episode, we've explored the role of AI in the broader e-mobility context and really tried to kind of lay the foundation of everything that's coming in the next couple of weeks, which is insights from several startups and companies across the battery lifecycle on how AI is used in those areas. And in this episode, we're diving into our first use case right at the beginning of the life cycle in the area of battery chemistry and design. And I'm really super humbled and excited to have Dr. Jason Koeller with me, who is co-founder and CTO of a startup called Chemix. And Chemix is a cutting-edge company focusing on developing advanced battery chemistries using AI to accelerate the discovery of new materials, optimize the performances, and I'm sure many more things that I'm really excited to talk about. Jason, it's really a pleasure to have you here. Thank you so much and welcome.
Thank you, Veronika. Yeah, it's great to be here.
Awesome. Where are you dialing in from?
From San Mateo in the California Bay Area.
Oh, that's very nice. Let's just start. Maybe you can tell us a little bit about yourself, your life, your career so far, and how Chemix came to life.
Sure. Yeah, I have maybe a somewhat unconventional background. I actually got my bachelor's degree and PhD in theoretical physics. And
Me too.
really, okay, there we go. I was really convinced that I was going to be a physics professor, and just kind of in undergrad and even in high school to some degree, the more I got into physics, the more I really enjoyed it, and kind of just went on a deep dive and got my PhD in quantum gravity, working on some inequalities relating information content in space-time in the context of black holes.
Wow.
But really towards, what was going to be kind of halfway through my PhD, I sort of started having a bit of an existential crisis, which was, while physics was really interesting, it just didn't seem like the time scale that we needed to solve these problems was anything, immediate. So while I still think that people should study physics, I sort of came to the conclusion that I didn't personally need to be doing it because the field would continue to go on, just fine without me. And so I started to think about and look at, what kind of problems are more pressing? Does it feel like it's really, we need more people working on them? And of course, where could I possibly have some impact with a background in physics? And so started looking at clean tech and clean energy and energy storage, and eventually kind of was following a lot of things and got into batteries, and actually decided to get my PhD early, to leave early and join a startup in the Bay Area, which then was only a handful of people, called 𝗟𝗲𝗄𝗏, working on lithium metal batteries. And I was actually the third full-time employee there, learned a lot about batteries, kind of almost got a second PhD in battery science there, and really enjoyed that. It was a great team. But at the same time, a lot of my former colleagues from physics started getting into machine learning and AI. And there's actually a lot of physicists who go into AI for various reasons. But so I kept hearing about it from people. Even though I was working, full-time on batteries, I was sort of researching machine learning and learning about it kind of in my spare time on the weekends and so on. And it was really interesting, but I didn't see the sort of direct connection with what I was working on at 𝗟𝗏𝗄𝗏. But as the company grew and as we started gathering more and more data at 𝗟𝗏𝗄𝗏, I started to wonder if perhaps some of the data analysis and data processing things we were trying to do could have been sped up or improved with machine learning and AI. So that was kind of just in the back of my mind. And then the more I kind of started thinking about this and investigating it, the more I thought, there's something really interesting here. And so I actually left 𝗟𝗏𝗄𝗏 and became a data scientist at a company called 𝗟𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏, working on materials discovery. Worked with a bunch of different companies all over the world, actually, on speeding up materials development problems and materials discovery with machine learning. And, that worked well. But also at the same time, I was constantly thinking about the fact that if we just had more data and if we had experimental processes that were really designed from the ground up for this use case, for being processed and analyzed by computers rather than humans, that we could do things in a very different way and potentially have even more, significant performance improvements. And so that's more or less how Chemix came about, actually, which is kind of asking these questions about, it's great to use machine learning and AI for materials discovery, but what if we had more data? What if we could build models that were specialized for batteries, for specific battery processes? What if we could fully integrate software, machine learning, AI, battery experiments, and battery data? And, at the limit, what this looks like is basically a self-driving lab. This is a term that academics have been using lately to describe this process where AI and software basically completely controls a research lab. It designs what experiments would be run. It processes the data. It sends samples around with robots, perhaps, to different analytical equipment. And then it processes the data, cleans it, and it actually builds a model of the different processes that are going on inside those materials and those devices, and then uses that to navigate this very complex space of materials and formulations and designs in search of optimal performance. And so that's essentially what we've done at Chemix, actually, is, with my co-founder, we started this Chemix with this vision in mind, a fully vertically integrated AI for battery company, where rather than kind of combining two separate systems, one traditional materials development and one, software platform, say, they're integrated deeply from the ground up.
I love that. You really have a very inspiring story, and I love the vision of Chemix, and we'll talk about all the details in a little bit. Before we dive into the real use case and like your product and the vision that you just shared, I would love to understand a little bit better your usage of AI in your personal life, because I designed this podcast series to really help people understand the value that artificial intelligence in general can bring to us as individuals, to organizations, and then, of course, the wider industry, which is the e-mobility industry in our case. So maybe we start with a simple and very hard question. How do you define artificial intelligence?
Yeah, good question. And I actually really appreciate the way you structured it, because I think a few years ago, even when we started Chemix, this would not have been top of mind for people, but it's great to see the awareness. So one way of thinking about AI is it's a way of essentially mapping correlations. So you've got some inputs and they produce some outputs through some kind of process or system that you don't really understand. And AI is a way of basically finding which combinations of the inputs relate to particular outputs you're interested in. Another way of thinking about AI, which is also quite interesting, is it's sort of a way of programming, except instead of writing code where you tell a computer directly what to do, you show it many, many examples of what you want it to do, and it learns those correlations, and therefore it can do things on its own that potentially you couldn't even do yourself, because it can understand these correlations, how the inputs relate to the outputs. And the reason why this is interesting, of course, there's a lot of use of just, having computers do things that humans can do very well, but it's cheaper or faster.
Yes.
But I think it's really interesting when computers can actually do things that humans cannot themselves do.
Yes.
That's basically what it means to me.
Awesome. So then do you use AI in your personal lives?
Yes, definitely. So personally, I use, in non kind of Chemix context, I use mostly Claude from Anthropic, which is one of these large language models. I use it to teach me things, write code for me sometimes summarize long documents or answer questions about long documents for me. It's really quite impressive how good these systems have gotten, these generative large language model systems. And I think there are way more use cases coming, but this is just kind of how I use it day to day.
Yes. And then besides what you already shared and really the product and the vision that you have for Chemix, is there anything about AI that you use in your organization, such as onboarding or sales or any type of chatbots or all that stuff?
I would say we largely use it in the context of traditional uses of AI for like enterprise, productivity tooling. Largely use it in the way I described. So a lot of employees use it to learn new things. We write a lot of code with it, and again, to summarize documents and help draft emails and things like this, the sort of standard stuff. But what I'm most excited about is where AI comes in directly in the battery development and the battery use case. And then these are completely different models, not, text-based large language models, but models specifically developed for battery development.
Yes, and this is exactly what I want to talk about in this podcast today, and really also understand what is the difference between AI in personal life and increasing productivity and large language models and text-based, video-based and all that, versus the AI that we use in products such as yours. So let's talk a little bit about your use case again. So you explained it already a little bit, but maybe your little elevator pitch. What is Chemix at its core?
Right. So at its core, we're essentially an AI and software-powered battery company. But there's more to it than that, because in the battery industry, we don't automatically have tons of data at our fingertips, like in the case of text-based language models, where you essentially have tons of text and training data on the internet. So we're actually a data infrastructure company in a sense as well, because we do spend a lot of time thinking about how to efficiently get high quality, high quantity data for whatever types of problems we're trying to solve with AI. And we're really vertically integrated in the battery ecosystem, which means that we focus on batteries, but it means that we're applying AI to solve many different problems within the battery industry. And this is including battery development, battery qualification, but also repurposing, state of health estimation, remaining useful life estimation, and these kind of things. Basically anything where physics-based models or human intuition are not so good or not sufficient to solve the problem, but where we can feasibly gather lots of data and answer these questions in a data-driven way. And at a high level, if we kind of just zoom out, like what is the core problem we're solving? The core problem is that batteries at some level of detail are basically black box systems. It's true we understand approximately how they work, but to answer very specific questions like how will changing the concentration of this additive in the electrolyte affect the cycle life, or exactly how will this battery perform if I use it in this use case, given that it's already degraded by this amount from this other use case. These kind of questions are, from the purposes of answering these types of questions, batteries are more or less a black box. And
Yes.
what we're doing at Chemix is using AI to essentially illuminate this black box. And that means that we can then address questions or problems in battery development, in battery qualification, and battery usage, repurposing, and so on.
Yes, I love it. And this is actually the reason I initially started in the battery industry. So I also have a PhD in theoretical solid state physics in my case. And, I was just used to really looking at molecular scales and density functional theory, atomic scale, and all that. Then I started in the battery field, and I was just surprised how much we don't know about how batteries age and all the processes going on, and how can we optimize lifetime and all that. So it's really intriguing to me still what we can do here. So I'm really excited for what you do. In order to understand a little bit better also where you contribute, let's talk a little bit about how are batteries traditionally developed? How does the process look like? How long does it take typically to come up with a new battery chemistry and design?
Right. So traditionally, battery development is fairly slow, manual, and expensive. And it's essentially, at some level, boils down to brute force trial and error. Of course, in the beginning of the development process, you have a high level understanding of what kind of performance you're trying to get. And so therefore, at a high level, which materials are likely to be appropriate. But when it gets into the details, basically beyond that kind of first one or two steps, pretty much anyone who's, an expert in the field will admit that at some point, they don't exactly know how making a small change or even a large change is going to impact a particular aspect of battery performance. And significant part of the problem is, it's hard enough to optimize for one of these performance metrics because the battery is such a complex and highly coupled system where changing one thing can have all these downstream effects in other parts of the battery. But then it's made even harder by the fact that there are multiple performance metrics that you need to optimize for simultaneously. And so essentially it boils down to this very high dimensional input space, which is all the materials, all of the concentrations, the battery cell designs, how they're processed, and then also many output dimensions, which is cycle life, calendar aging, internal resistance, capacity retention, all of these metrics that people care about. And holding all of that information in your brain at once and trying to kind of make sense of it all is very challenging for a human. Humans are really good at things where we can, distill them down to specific physical principles and abstract, generalize out like simple mathematical laws that govern a wide variety of effects. But here we have kind of the opposite effect where it's you've got simple laws, but they don't apply in the detail you need. And so it's a matter of just letting the data speak for itself. And so, but typically the process is, human researchers have some idea of what they're trying to develop, go to the lab, run some experiments based on some intuition, spend some time analyzing that data, maybe waiting for battery tests to complete, maybe waiting for months for cycle life testing to happen, and then trying to understand based on the results they saw, like what should they change. And at some point, it's just basically brute force trial and error.
Now, how can this be done better with Chemix? And I actually wasn't aware that with your use cases, you are actually touching on the entire value chain, but for simplification and also for people to understand better, let's really just for now look at the material discovery, new battery chemistry design aspect. So what does Chemix do here to change that?
Right. So, at the very beginning, one thing that's quite different is that we don't claim to know or necessarily even try to know the exact relationship between battery chemistry, formulation, and design, and the battery performance. I think at pretty much any other battery company that you go to, there are scientists, there are people who have spent their entire careers trying to understand how these things work, and they definitely want to try to understand how they work, and they're going to try very hard to understand how they work. But we, in some level, don't even bother with that. Instead, we perform experiments and let the data speak for itself, and we put all of our effort into figuring out how to run these experiments, how to run as many of them as possible, how to collect high quality data, and then how to learn from them most effectively. And that's where the AI comes in. And so this is really an example of what I was talking about before, which is with AI, we can actually get a computer to do things that we don't even know how to do, such as predict battery performance from battery design, because we can just show it lots of different examples of this, thousands and thousands of examples of, this recipe led to this performance and this recipe led to this performance. And it can essentially memorize all of that data and build a model for it, and interpolate between those data points, and even extrapolate to some unseen situations. And then essentially, we just run experimentally those unseen situations that are either most promising based on the model, or most uncertain based on the model, or some, most likely some combination of the two. And this is this kind of concept of the exploration-exploitation trade-off. When you're doing any kind of optimization problem, you can run experiments that teach the model a lot. We can run experiments that are likely to perform very well. And in reality, we run both. And then over time, this AI system autonomously by itself navigates the design space by iteratively trying new chemicals, changing their concentrations based on the results, and in fact, even scanning through libraries of existing chemicals that we can purchase, bring in-house, add them to the database. And it's really this systematic, principled, still trial and error, but trial and error that is governed by a model that knows as much as possible about the system and can learn efficiently from the process.
Just to understand better, what level are we talking about? So you mentioned like different chemicals that you can put together. So are we then talking about the cell level, or what is the actual battery that we're looking at in your software?
Right. And maybe it's helped talking to discuss a little bit the business model. At the end of the day, what we make are cells. And so customers want to buy cells, right? And as the EV industry takes off, there are more and more need for cells and more different types of cells that are customized for different applications. So that's the ultimate product. And at the end of the day, that's the thing that we care about the performance of. And those cell level metrics I mentioned, cycle life, energy density, capacity, and so on.
Okay.
The things that we're optimizing, basically, the inputs to the AI system are essentially exactly what materials are in those cells and exactly how much. A battery is basically a formulations problem at the end of the day. There's certainly some processing going on as well with the electrode coatings and mixing and, the coating process. But at the end of the day, the performance is largely dictated by what is in there and how much of it is in there. Classic example is the electrolyte, where, researchers study this over decades and still don't understand completely why, adding 1% of a particular molecule can double or triple or even 5x the cycle life. Adding another molecule can increase it further, but then adding a third one makes it much worse. It's highly nonlinear. So that's the level that we're optimizing at. So every day we're actually building new battery cells in the lab with different concentrations and ratios of different materials and testing how they perform based on those inputs.
And if we think about the cylindrical, pouch, prismatic, so you have a variation of all those formats in different thicknesses, different materials. Is there also something like the outside pressure on cells or even the formation process and stuff like this? Can you include that in the models or software too?
Yeah, that is included because it affects the performance.
Yes.
So the philosophy here is that anything that can be controlled is controlled. Anything that cannot be controlled should be measured. And based on those two things, we can predict what the performance is going to be with enough accuracy to iteratively scan through the design space. So it is true that the formation protocol has a significant effect. The charging protocol has a significant effect. And the testing conditions. Also, the testing protocol itself. What rates are you charging and discharging? How long are the rests? What temperature is this occurring at? How are the cells cooled? All of these kind of things.
Oh my God, I'm so intrigued. I want to try this. Who is your typical client? I guess it's not Electrified, Veronika. And how do you work with your...
So typical clients are any companies that are buying or managing batteries. And so, mostly this is EV companies or companies doing grid scale energy storage systems. From their point of view, we're a battery company. We're selling them cells. And the way we work with them is we understand their pain points with today's off-the-shelf batteries based on whatever the system is they're trying to design. If it's an EV, what is the form factor of the EV? What kind of problems are they having with today's cells? How do they want today's batteries to be better? And then we basically come up with a list of very specific performance metrics. And then we set our AI-based self-driving lab process in motion to improve the battery performance to meet that need. So essentially, we put those targets in the system and get it set up. And then every day, it's iteratively designing new experiments. Those experiments are then run in the lab. The data is collected, processed, and so on. And the process repeats.
So you're not working with the cell manufacturers then. So you're more working with the integrators, and they're using your product almost like as a virtual battery cell, something like that?
So actually, our product is the batteries. All of the AI system and process I developed is what we use internally to develop those batteries. Okay, and then we actually get those batteries made by existing battery manufacturers who are very good at mass production at high quality and high scale. And so essentially, there's like a three-party arrangement between us, the customer of the batteries, which is the EV company, and then the company that actually makes the batteries.
Okay, perfect. Now I got you. That makes a lot of sense. Let's talk a little more about what type of AI you're using in Chemix. And I specifically also want to understand a little bit better the difference between classical machine learning, because, when I did my PhD, we looked at how would molecules arrange on surfaces. We would apply machine learning, but nobody would ever call that AI. Can you define for Chemix, what type of AI are you using?
Yeah, actually, maybe it's just interesting to kind of address the question you just asked, which is like basically the definition of these terms, because they are used very sort of almost interchangeably. So to me, machine learning is literally when you teach a machine to learn by showing it examples. And typically the word machine learning refers to smaller models, more classical models, basically before deep learning. So basically before, 2010, 2015, that kind of time. AI traditionally has basically referred to a system which operates like a human intelligence. It doesn't even have to be based on machine learning at all. People were doing AI with non-machine learning systems, decades ago. But these days, people also use AI to refer a lot to very complex and, large machine learning models themselves. Yes. So, a generative, and then there's the question of generative AI, which is just an AI system that actually generates something new rather than just predicting a number or a classification label. And so at Chemix, we are certainly using AI because the system we're developing is basically replacing human scientists, which is certainly, a form of intelligence. And it has machine learning as a component to it, but it's not just machine learning. Just machine learning enough would not be enough. And it actually is generative because every day we are generating new battery designs. And so it's a generative AI system. Something like ChatGPT, you could think of as actually a generative machine learning model if you want. It's a machine learning model and it generates, and then it's sort of smart enough that people start calling it AI.
And then how does a digital twin fit into all this?
Yeah, good question. So to me, digital twin is basically where you have a virtual or digital replica of some physical object, and you can actually, in some sense, perform experiments or interact with that system in the virtual way rather than actually having to interact with the physical system. So this makes a lot of sense for, manufacturing equipment or something like that, where you have this large piece of equipment. It's very expensive. It's very hard to tweak and, maybe takes a long time to set up and operate. And if you have a digital twin, then you can run all kinds of experiments to figure out how should it be used most optimally. But you can also have a digital twin of a battery. And this is actually something we're working on, which is if you've extracted enough information from a real live battery such that you have enough information to make a digital version of it through some model, then now you can interact with that battery in a virtual way and basically probe its performance, find out, how well is it going to perform if I subject it to this different operating condition. And then you can answer those questions without actually having to physically test it.
This is something that I actually also worked on. One of the use cases was really building up a digital twin of a battery that runs in real time in a lab. And at some point gets so good that you can say, okay, I can stop the physical testing now. And as you mentioned, lifetime testing of several months, maybe even years. we can then very early on say, okay, we can stop it because we can actually predict the outcome.
Right. There's some very interesting stuff we can do there using a lot of these more recent generative sequence models, which is quite interesting. We're going to have some results on soon.
I love that. And I could talk to you about this for hours, I guess, but in regards to time, I need to speed up a little bit. So maybe one last question about your use case as such. What about some challenges or risks associated with AI? And then also when you work with your clients, how is the general mood of using AI in your whole product and tool chain?
Yeah, it's a good question. The main challenge I would say is still the amount of data. I mean, I think this is a challenge that's never going to go away because these systems, these AI systems, it's almost always easier to develop bigger models and scale up the compute than it is to get more data. And so even for a large language model like ChatGPT or that style of model, people are talking about, where can we get more data? And that level of internet scale data is, if people are still looking for more data in that context, then of course in any kind of real world physical application, there's going to be a scarcity of data at some level. So it's always going to be a challenge. But again, at least we're taking that matter into our own hands and kind of controlling our destiny there by doing our own experiments and owning our own data. Sorry, what was the second thing?
Kind of the sentiment of
right.
AI for your customers.
Well, so from their point of view, it's interesting, right? They really don't care how the batteries are developed. They just want better batteries. And I think so at some level, the AI is really only interesting to them to the extent that, it gives them some confidence that what we're doing will be better than something that's off the shelf. And which for an early stage startup, of course, it's helpful, right? You need to have customers need to have some way of working with you before you've kind of proven the results to them. But then there's a second component, which is, again, around the management and the utilization and sort of the continual feedback of once the batteries are in the field, actually in vehicles, they're generating data. And then how can we use that data basically to further optimize for that specific use case and that specific vehicle design? And so the customers see that as another value add of our AI capability, which is that we're actually a long-term partner for them. And we're not just selling you here's a cell that we try to sell to, a bunch of different people. This is something that's for you. We're going to be partners with you in the long run, and we're going to continue to improve. And we're actually going to give you more kind of value add along the way.
Okay, amazing. One last question would maybe be a little bit about a concrete use case or a couple numbers, some metrics that you can share. I don't know if your customers are more those who maybe have an existing product, existing cell, and they ask you to make it better, or if they are customers who want a completely new cell. But what are the conversations that you have? What are the requirements that they give you, or what are they asking for? And how does this turn out?
Yeah, there's a bit of both types, but usually the way this goes, whether it's an existing cell they want improved or whether it's just, something completely new, usually it's phrased in terms of specific performance requirements. So cycle life, energy density, charge rates, discharge rates, internal resistance, and so on. And so far, we've developed a state-of-the-art chemistry and cell design for one of our early customers, which we call Jade, which is ideal for high performance, but still cost sensitive, which most applications in the EV space are still cost sensitive at some level, no matter how high performance they are. Applications in passenger vehicles, sports cars, motorcycles, things like this. So where performance matters, where there's going to be a lot of power requirements, a lot of acceleration and regenerative braking, but energy density is still important, cost is still important. And it actually has high power, like I mentioned, but also very high safety, good energy density, and very long cycle life. And so this is a brand new cell that we've developed, and it's manufacturable with today's existing lithium-ion production lines. We've actually produced and shipped to customers more than a megawatt hour of these cells for initial builds and validations, and the feedback so far has been quite good. And then apart from that particular product, we have other things in the works that are at various stages. Just a few quick examples. We've been able to design a battery which can demonstrate significantly longer cycle life under various challenging conditions, such as, fast charge, which usually degrades cycle life. We've seen more than actually a 7x improvement in cycle life under some very aggressive fast charging situations. 3x improvement in cycle life under a continuous high temperature operation. So if you expose these batteries to high temperatures, much higher than typical batteries you would, significant improvement in cycle life there. And then also significant improvement, about 3x in cycle life for some high energy density chemistries that are still kind of pre-commercialization because their cycle life is not yet sufficient. And there are other exciting things in the works and that I can't quite talk about yet, but making good progress.
Well, thank you. And thank you for sharing a little bit what's what's next for Chemix, which leads me into the last part of our little conversation, talking about the future of AI in our industry. What do you think, what's the next big thing for our industry, or in general, how is the whole e-mobility battery industry evolving now? There is all those tools there is large language models, there is of course all the machine learning and deep learning side of things. Where do you
Right.
see it headed?
Right. Well, it's definitely an exciting time. I mean, what I'm most excited about, again, is this kind of integration of AI with battery development with lots of other things. I think over time, AI will become more and more embedded into many different processes and products and services. And we're seeing this first with things like, text-based large language models and so on becoming more and more embedded. But I don't think this is going to happen everywhere all at once. There will be like leaders who basically adopt AI into their product and services first. And there is some upfront cost associated with this, especially if it's a physical product, because you have to develop the data pipelines to generate all of that data to then power these AI systems. But the interesting thing is that once those data pipelines are in place, then now those sort of AI-enabled products and processes are just continuously gathering data. And then that data is only being generated for those situations. And so as the data accumulates, and as AI just gets better in terms of the models themselves, then there's, I think, going to be a separation between the products and services and companies that basically made that investment early on, accumulated all that data, and then those systems are going to be significantly better than ones which have benefited maybe from developments in the AI algorithms, but wouldn't have this amount of data accumulated over time. And so I do think it's important to kind of get started early with this so that that data collection can be built in.
Yes, and it's also my experience. I have tried that now a couple times to help customers integrate AI into their products, and especially for those who have their existing infrastructure set up, it's just so hard to even just get data curated at the right time in the right format. And maybe that's even 90% of the work, and then only can you even start thinking about adding AI and all those magic elements to the story.
Absolutely been my experience as well. Yep.
Yes. Thank you so much. Is there anything else you would like to add or mention at that point?
Well, I've alluded, we do have some exciting stuff coming up, which we'll be releasing and announcing soon. So stay tuned for that. And then, I always like to say, anyone who's interested, batteries and AI are two of the most exciting fields right now. So anyone who's interested in working kind of in that intersection, please feel free to reach out to me on LinkedIn. I read my messages and be happy to chat.
Thank you. Thank you so much, Jason, for sharing your story and giving such great insights into everything you do with Chemix. In the next episode, I will be speaking with Monolith on how they use AI in the area of battery development and testing. So thank you again, and thanks everybody for listening. Bye.
Thank you, Veronika.